Krishna. Here my teammates are Udayati, Vedika Sar number. Now we are going to present a topic about vehicle Autoturn system with the drowsiness reduction using 8051 microcontroller.
Now let's see how to simulate this project using Kale software and Proteus. So firstly open the Kale software. In the Kale software, go to project and click new microvision project. Then give the desired file name and click save. After saving it, you will see a pop-up window where it will show select devices for target 1. In that, type 8089C51 and click OK. Once you click OK, you will get your project name which is displayed above. Then go to File, New and give a new file. Once the file is created, type your desired code. After typing the code, go to target 1 and set the target which is the crystal oscillating frequency to 11.0592, and after that go to output and click create hexa file and give OK. After this, go to save and save your project with the desired name with .c extension. After saving it, to the leftmost corner below the target 1, you will get source group. In the source group, right click the source group, and in that you will get an option add existing file to the source group. After clicking that, you will get an option to insert your file into the project. Once it is inserted into the source group, you can translate, build and rebuild your code to check for errors. If there is any errors, it will be displayed below. So correct the errors and then again translate it, build and rebuild it. After building and rebuilding it, you will get the debug option at the rightmost corner. So you can click that to see whether you have any errors further. After this, go to the Proteus software and give the desired connections according to your system. After giving the connections, click on to the microcontroller and give the location where your file is saved in the Kale software. After giving the location or the path for your code, then at the leftmost corner you will have the run button. Once you click it, your output will be verified. Now let's see the working principle of this project. The system operates based on simple yet effective logic using IR sensor and a microcontroller. Its main functions are to detect driver drowsiness and automate vehicle turning, and it achieves this through continuous monitoring and motor control. Firstly, let us see the IR based hand detection. In the IR, sensors are placed on or near the steering wheel where the driver is expected to grip. These sensors emit infrared light and measure the reflected signal. When a hand is placed near the sensor, the IR light reflects back and the sensor registers the presence of the hand. If the hand is not detected for a continuous duration, say example for 5 seconds, the system assumes that the driver may be drowsy or inattentive. This is a non-contact method of monitoring, making it simpler and cheaper than camera-based tracking system. Secondly, the drowsiness detection logic. The 8051 microcontroller constantly reads signal from the IR sensor. If the microcontroller receives no signal indicating hand presence over a preset duration like 3 to 5 seconds, it considers this as drowsiness or loss of attention. Once this condition is met, the microcontroller will activate a buzzer which gives an audible alert to the driver, potentially waking them up or regaining their attention. The time delay before triggering the buzzer can be modified in the code to suit different conditions accordingly. Thirdly, auto-turn detection and control. The system is also designed to simulate automatic turning based on steering movement. When the driver moves the steering wheel, the IR sensors detect the change in position or grip. The 8051 microcontroller will analyze which side of the steering was touched or moved and accordingly sends a control signal to the L29-3D motor driver IC. The L29-3D acts as a switch to control the DC motors that simulate the vehicle's wheels or steering system. For example, if the right side IR sensor is triggered, the right turn motor is activated. If the left side sensor is triggered, the left turn motor is activated. Now let us see the output indicators. The system includes an LCD system that shows real-time messages such as turning left, turning right, drowsy detected, etc. These messages will help us to visualize the system responses and confirm that the logic is functioning properly. So, to see about the power and safety, the whole system is powered using a regulated 5-volt power supply. The circuit is designed to use low power, making it suitable for automotive or portable use. Since it does not depend on a camera, lighting conditions do not affect the performance of the system, making it more robust for real-world use.
Explain the overview of the system. This aims to improve the vehicle safety by addressing two critical aspects. Firstly, detecting when the driver becomes drowsy, which is a major cause of accidents. Secondly, automatically responding to steering movements to assist in controlled vehicle turning. Here we choose to use 8051 microcontroller due to its simplicity and reliability in handling the embedded control task. The major reason to choose this problem statement is in concern of the road safety. Many studies shows that many road accidents, especially on highways, occur due to two reasons: drowsiness or fatigue of the driver, especially during the long drives or night travel, and also the incorrect or delayed steering controls, which may cause the vehicle to drift or turn suddenly. Modern vehicles come with driver assist systems, but these are mostly present in high-end models and are too expensive for regular vehicles. Here we need an affordable solution that provides solution in both the aesthetic problem. Current drowsiness detection system mainly rely on image processing and eye blink detection using cameras. Major drawback of using an eye blink sensor and image processing method is due to its high cost and the privacy concerns of the camera. Increased power consumption and dependency on lighting conditions. Hence, they are not suitable for small vehicles, two-wheelers, and commercial use in low-budget regions. In our proposed solution system, we are using an IR sensor to detect the presence or absence of a driver's hand on the steering wheel, which indicate the attentiveness. If no hand movement or grip is detected for a few seconds, the system assumes that the driver is drowsy and triggers a buzzer. Simultaneously, if the steering is moved, the system detects the direction and automatically turns the vehicle using the DC motors. In this system, no cameras are used, which reduce the cost and complexity. Fast response using the real-time IR sensing is detected, and also simple integration into low-end or two-wheeler vehicles, which provides a cost-efficient and safety mechanism for a wide range of vehicles.
Let us implement the system into two phases. One is simulation phase and another one is hardware phase. First, we shall see the simulation phase. Using Proteus software, we created the output and tested with logical input to hand detections and the movement. The microcontroller code was written in embedded C program and loading into the simulation, observing the output like motor movements and buffer alarm. Next is hardware phase. We built an prototype using 8051 board, IR sensor, a small DC motor setup and buffer. We observed that when hand was placed near the IR sensor, the microcontroller interrupted it correctly and controlled motor direction. When hand was present for a set time 3 to 5 seconds, the buzzer was triggered, effectively warning the driver. This shows our design was functionably and reliably. Now let us see the applications. Our system has wide range of practical uses. Two-wheelers and scooters, auto rickshaw or trucks, buses, school vans, etc. To summarize, our system combines two important safety functions: auto-turn detections and drowsiness alarm, using simple and hardware. It uses IR sensor instead of camera. It's run on 8051 microcontroller, which widely available and easy to program. It's avoid complex system and focus on real-time safety at low cost. This is an scalable project, and in future we can extend for further like GPS alarm, vibrating motor, or even mobile notification to.
Now, let's see the key advantages of the vehicle Autoturn system with drowsiness detection. Firstly, enhanced driver safety. Alerts the driver in case of drowsiness, reducing chances of accidents due to fatigue. Secondly, hands-free turning assistance. Automatically detects turn intention and assists in steering, helping during critical turns. Third, low-cost implementation uses affordable components like IR sensor and the 8051 microcontroller. Fourth, non-intrusive monitoring detects drowsiness without requiring eye tracking or cameras, preserving driver comfort and privacy. Fifth, real-time response quickly detects issues and responds with alerts or steering assistance in real time. 6. It is simple and compact design, easy to integrate into existing vehicle system with minimal hardware. Lastly, scalable and upgradable, can be extended to include additional features like GPS, speed